Okay, class, so this is Algebra 1, Lesson 10.4, Factoring with Special Patterns. All right, so far we learned to factor out common factors first, and we also learned how to factor trinomials by trial and error. So now, a real important pattern. So this first one comes up all the time, really, really important. It's called a difference of two squares. A difference of two squares. A difference of two squares. All right, how does that go? What does the name have to do with anything? All right, the minus sign right here is the difference part, okay? Subtraction. And then of two squares, notice you've got a perfect square there, and you've got a perfect square there. So again, these are perfect squares. Hence the name, the difference of two squares. Now, notice you have a binomial. That's important. It's a binomial. So we've got a polynomial with only two terms. It's got to be a binomial for it to be a difference of two squares, and so it's important that you recognize that. So how do you recognize a difference of two squares? First off, it's a binomial, right? There are two terms there. The front term is a perfect square. There's a minus between, and the back term is a perfect square. And when that's the case, you've got a difference of two squares. All right, let's factor it. Let's learn the pattern. Well, like always, your first thought should be factor out common factors first. Now, you always got to look. Now, in this base pattern here, there are no common factors, but you always have to look. What's the next step? You make two parentheses. You always make two parentheses. And the parentheses are going to be multiplied times each other. All right, you make two parentheses. Next thing, this always happens. Take your blue, put a plus in the middle of the first and a minus in the middle of the second. Now, I will tell you this, some like to put a minus in the middle of the first and a plus in the middle of the second, but according to what property, that won't matter. And I hope you're thinking the commutative property, right? So really, I mean, it doesn't really matter. I always like the plus first and the minus second. Okay, what do you do next? Well, here's the pattern. You put the square root of the first term first. So look underneath 4 here. We want the square root of the front x squared term. So that's what I'm going to put first. Square root of x squared goes in the front. Square root of the front term. And what do you do next? Number 5, the square root of the last term. So I'll put the square root of y squared in the back. Now, we are not going to show these square roots past this first example, but we're going to think them, okay? Because this is what we do. Square root of the first term in the front, first in each parentheses. Square root of the last term, last in each parentheses. Really easy. It's really, really simple. So look where we end up. Let me get rid of all of this. And where do we end up? In the front parentheses, you end up with an x plus y. And in the back parentheses, you end up with an x minus y, right? And that is a difference of two squares. So technically, x squared minus y squared equals quantity x plus y times the quantity x minus y. We've had these already, remember? When we were multiplying them. If you remember, when we were multiplying two binomials, we said, oh, this is a difference of two squares, and when you multiply it, you get that. Well, remember, factoring is unmultiplying. We're unmultiplying. So now we got to learn to go the opposite direction. Okay? They're not hard. They're not hard. They're not hard. Let's do some examples. All right, so here's our next example. We've got a squared minus 9. First off, recognize, is it a difference of two squares? Is the first term a perfect square? Yes. Is there a minus between the two terms? Yes. Is the back term a perfect square? Yes. It's a difference of two squares. All right, what do you do first? Factor out common factors first. There are none, right? But you looked. You thought about it. You got to think about it. What comes next? Always two parentheses. What do you do next? Take your blue, put a plus in the middle of the front parentheses and a minus in the middle of the back. What's next? The square root of the front goes in the front. Now normally we won't show the square root. So here underneath number 4 over here, I'm going to write the square root of a squared equals a. And I'm going to put the a in the front, right? And normally I'm just going to think through this, but I'm trying to show you here on the right what your thought process is. Oh, and by the way back up here with my green, completely factor these difference of two squares. Right? Recognize the name. You'll hear me say it a lot, and if you'll recognize it, it'll go quicker for you. Okay, and in the back, how do you get the last term? The square root of the last term. Square root of 9 is 3. So we put a 3 in the back of both, and that's it. The quantity a plus 3 times the quantity a minus 3. Hey, these are easy. You can factor a difference of two squares. They're really, really easy. You really don't want to miss any of these because they are not hard. Okay, here's our last example on the front page here. So again, you look and say, hey, is this a difference of two squares? First off, it's got to be a binomial. Is it a binomial? Yes. Is the first one a perfect square? Yes. Is there a minus between them? Yes. Is the back a perfect square? Yes. All right, good. Got a difference of two squares. Like anything you're factoring, factor out common factors first. There are none. But you looked. Next. All right, so if you want to pause the video and do it yourself, all right, either you pause it in your back or you didn't pause, you do two parentheses, plus in the middle of the front, minus in the middle of the back. I'm going to take my red, the square root of the front goes in the front, square root of n squared is n. Square root of the back goes in the back. Square root of 49 is 7, the square root of p squared is p, so 7p, 7p, n plus 7p, and minus 7p. Not too hard. Difference of two squares. Let's do a couple more here. C. All right, be careful with a 1. A 1 is a perfect square. It works fine. Factor out common factors first. There are none. Again, if you want to do it yourself, go ahead and pause the video. All right, what's next? Two parentheses. Plus in the middle of one. Minus in the middle of the other. Taking my red, square root of the front of the first goes in the front. Square root of 4 is 2. Square root of a squared is a. 2a and 2a. Square root of the back goes in the back. Square root of 1 is 1. Square root of 1 is 1. There we go. 2a plus 1. 2a minus 1. Right? They're not hard. They're not hard. Watch again. Look, two parentheses. Plus in the middle of one, minus in the middle of the other. Square root of the first goes first. Square root of the last goes last. That's it. You're done. But you got to know that, okay? You got to know that. All right, how about this one? You want to do it on your own? Go ahead and pause the video. If not, you can wait. All right, if you're back or you paused or you didn't pause, did you factor out common factors first? I hope you factored out that common 3. That leaves us an x to the 4th minus 4. And that's where we're at right now. Now this binomial is a difference of two squares, right? Okay, don't forget to include whatever you factored out for common factors. Then come your two parentheses. Plus in the middle of one, minus in the middle of the other. What's the square root of x to the 4th? Do it off to the side here. What's the square root of x to the 4th? And I hope you think x squared. So x squared goes in the front of both. And we all know the square root of 4 is 2, so 2 goes in the back of both. There you go. 3 times the quantity x plus 2, x squared plus 2 times quantity x squared minus 2. Let's do another one. All right, how about that one? So again, if you want to do it yourself, go ahead and pause the video. All right, did you take out the common 3y squared? I hope you did. What does that leave you? It leaves you an x squared minus 25. And here again is our difference of two squares. A binomial, perfect square in the front, minus sign, perfect square in the back. All right, as always, don't forget what you factored out. then your two parentheses, plus in the middle of one, minus in the middle of the other. This should be your thought process. Square root of the first goes first. Supposed to be my red there. Square root of the back goes in the back. What's the square root of 25? It's a 5. And there we go, 3y squared times the quantity x plus 5y times the quantity x minus 5y. Hey, factoring the difference of two squares. It's not hard. But please remember, factor out any common factors first. All right, one last thought. These last ones I'm not a big fan of. Oh, I've got one more. Difference of two squares. Oh, yeah. I can't forget that. Man, I want to show you guys this one. So let me go ahead and... All right, I'm not seeing my shades, so I'm just going to leave it. Okay, focus your attention right here. Okay, this seemingly is not a difference of two squares. However, we can kind of still factor it that way. So do you see any common factors? The answer is no. Two parentheses. Plus in the middle of one, minus in the middle of the other. Can you finish it? Go ahead and pause the video. See if you can finish that. All right? See if you can finish it. All right. Hopefully you're unpaused now. What's the square root of 16n squared? A 4n, right? So the square root of the front goes in the front. So what do you do in the back? What do you do in the back? I hope you didn't come up with some decimal round off. You know how we don't like decimal round offs. Hey, look. Just leave it the square root of 7, right? 4n plus the square root of 7, 4n times the square root of 7, minus square root of 7. There you go. Factor that difference of two squares. All right, let's get to the last ones here. And these are perfect square trinomials. All right, you got to be careful in recognizing the pattern of a perfect square. What is the pattern? All right. If the middle is a plus, the last has to be a plus. All right, it's a trinomial. And then the middle term has to be the square root of the front times the square root of the back times 2. That's complicated. Square root of 1 is 1. Square root of 2 is 2. 1 times 2 is 2. 2 times 2 is 4. Okay, it worked. Oh, that's tricky. So here's the problem. Students can forget the pattern for a perfect square. So look, you know how you can solve this? You can just do it trial and error, right? Front term's an x squared. We know we got to use x and x. The back is a positive 4, and we're working towards a positive 4x. So we got 4 and 1 and 2 and 2. Hey, how about positive 2, positive 2? Doesn't that give me a positive 4 in the middle when I do my outers plus my inners? Isn't that the positive 4x I need in the middle? Sure it is. Now, by the way, how would you leave your final answer on this? You would do the quantity x plus 2 quantity squared, right? Perfect square trinomial. So what's the pattern? Here's the pattern. 1 parenthesis squared, square root of the front in the front, sine of the middle, square root of the back in the back. But you have to know it's a perfect square for you to do it. You got to know it's a perfect square. All right, looking at B. All right, B is a lot more complicated. But first off, what's your first rule in all factoring? Factor out common factors first. Let's take out a common 7. What are we left with? N squared minus 6np plus 9p squared. Okay. So again, to know if it's a difference of two squares, if you have a negative in the middle, this back sign has to be positive. It's the only perfect square. It's the only way it can be a perfect square trinomial. So again, see, there's a lot of stuff to remember, and that can be tricky. So you can just treat it as a trinomial and do trial and error. But if you know it's a perfect square, it is a little quicker. Let's just treat it as a trinomial. Okay, 2 parentheses. The front has to be an n and an n. The backs have to be a 9p and a p, or a 3p and a 3p. But remember, we got to end up with a negative 6 in the middle, so it's got to be, both have to be negatives. So what is it? A negative 3p, negative 3p. Again, when you do your check, the outers give you a negative 3np. The inners give you 3 more negatives of the np's for a total of negative 6. Yeah, that's the correct factorization. So here I'll do it on the final answer and show you how you would do it if you knew it was a perfect square trinomial. You would square it. You would go the square root of the first. You would use the sign of the middle, and you would go the square root of the back in the back. That is, if you knew it was a perfect square trinomial. Do you really need to memorize that? I don't think so, because it doesn't take that long to factor them by trial and error, and honestly, it's safer. So I'm not a big proponent of making you memorize perfect square trinomials or recognizing the pattern. But there is a pattern there, and those of you that are sharp and your mind works that way, you can use it. Just be careful. All right? So don't forget the lesson. The big key is difference of two squares. Boy, you've got to know this, that an x squared minus y squared, 2 parentheses, plus in the middle of one, minus in the middle of the other. Square root of the first goes first. Square root of the last goes last. Voila, you're there. All right, hope you enjoy the lesson.